All right, we're just going to jump right into it today. Okay? All in your notes. Don't need a piece of scrap paper or anything like that. Okay. So, what is the one rule of matrices that we talked about yesterday? I shouldn't say I didn't describe it yesterday as a rule. I described it as everything in a matrix can be described by 3 words. Nope. That's going to be too many words. What do you got? Put a word in between them. A 2-letter word. And it's the second letter. Rows by columns. Yes. Second letter, because it was B is the second letter in and Y is the second letter out. Okay. So rows by columns is the rule. Okay. Everything in a matrix is rows by columns. Okay. Everything. Size. Where the elements are, what you were saying, okay? The address of the elements, okay? Whether or not you can add, subtract them, okay? All that stuff. Especially today when we get into matrix multiplication. That's what we're going to deal with today, is matrix multiplication. Okay? So, let's do it. Here we go. Okay? So if I am going to multiply 2 matrices together, the very first thing that I have to do, before I can even begin to think about getting the answer, the very first thing that I have to do is I have to look at the dimensions. And I have to write out the dimensions in order, left to right. Now, up until this point in time, you have always worked under the assumption that it doesn't matter what order you multiply things in. Okay? 2 times 3 is the same as 3 times 2. Okay? You've had that, you worked under that constraint your entire life. Okay? That if order doesn't matter of multiplication. Okay? I am telling you that today, when we are dealing with matrices, the order is left to right. It cannot be right to left. Okay? So your order matters in multiplication. So you find the dimensions of your left matrix. So that would be these. Again, rows by columns. Then you find the dimensions of your right matrix. Again, rows by columns. Okay? And these 2 middle numbers, right here, right smack dab in the middle, these 2 numbers have to be equal. If they are not equal, you cannot multiply the 2 matrices together. Can't do it. Okay? If those 2 numbers are different, you're done. So that's why I say if we flip the order, if we switch to the order, we would have a 2 by 1 matrix times a 3 by 2 matrix, and now these 2 are not the same, and this is not possible. Okay? Has to be that way. So your order matters when you're multiplying. Because matrix A times matrix B might work, might get a resulting matrix. But matrix B times matrix A might not work. Okay? Okay? So the nice thing about that is also is that when these two numbers are the same, your outer two numbers are the dimensions of your answer. So this one multiplies together. These two matrices multiply together because those middle two numbers are the same. And the end result is going to be a 3 by 1 matrix. Speak now or forever hold your peace. You explain that in a much clearer way. Kind of muddy. All right, let's try some. The only other thing at the bottom here, it says, if this doesn't work, you can't multiply. So if you don't have that, you can't multiply the matrices. But we talked about that. Okay? So, can I multiply these two matrices? Yes, because these two numbers right in here are the same. So I can. And what would the resultant dimensions be? It would be a 2 by 5 matrix. Okay. My result would be a 2 by 5 matrix. Middle two numbers are the same. Doable. Result is outside in that order. Doable. Nope, not possible. These two numbers right here are not the same. Okay? Not possible, does not exist. Those are your two options for that. Okay? 0 is not an option because we could have a matrix that is just 0. All right, let's get into this. Let's do this. Okay? Now, I'm not going to say that multiplying matrices takes up space, but it has the potential to take up some space because it depends on the amount of work you want to do in your head. Okay? The more work you do in the head, the more chances are that you might forget something, the more chances because it's not written down, that kind of thing. So just so you know, the potential is there for these to take up some space, not as much space as 3 by 3 systems of equations. Okay? All right? So, first step to multiply matrices is you are going to make sure your dimensions work. Okay? So I'll give you a moment here to copy down these two matrices. Okay, so copy these two matrices down, please. So first thing is we got to do a dimension check. What are the dimensions of this left matrix? 3 rows, 2 columns, 3 by 2, I would concur. Okay. Dimensions of the right matrix. 2 by 1, 2 rows, 1 column, 2 by 1. Can I multiply these two matrices? Yes, I can. Okay. What will the resulting matrix be? It's going to be a 3 by 1, right? Okay. So what I'm going to do is I'm going to make myself a little bit larger 3 by 1 matrix. Okay. Where I'm going to put some stuff in there. I'm going to do all of my work in that space. Okay. So that's step number 1. figuring out if it works out or not. Now, step number 2 says, use the address of each resultant element to set up multiplication. Remember, it's rows by columns. So the address of this element is row 1, column 1. Agree? The address here would be row 2, column 1, row 3, column 1. With me on that? Okay? So what I'm going to do for row 1, column 1 in my resultant matrix is I'm going to take the first row of my left matrix and I'm going to multiply it by the first column of my second matrix. How I do that is I'm going to take 5 times -2, and I'm going to add that to 3 times 3. I take these two, and now this is a visual finger type thing. I take these two, and I multiply them in here. So 5 is my pinky, 3 is my index finger, so 5 gets multiplied by -2, and 3 gets multiplied to 3. Okay? I take this row times this column. I do that because I am right-handed, so I can do that literally on my paper while I'm doing it. Okay? All right? Then I go down here to the second row times the first column. So then that would be -1 times -2 plus 2 times 3. Then I go third row times first column, -4 times -2 plus 0 times 3. Want to know the biggest spot that people make mistakes? That's 0. Because people multiply it and they forget that 0 times anything is 0. So they see 0 times 3 and they think it's 3. Biggest spot for mistake because you're doing so much math and you forget those little things. Okay? So this is -10 plus 9, which is -1. This is +2 plus 6, which is 8. And this is +8 plus 0, which is 8. So my resulting matrix is a 3 by 1, -1, 8. This green matrix right here where I do all of my work, that could be a space saver for you, but then you're also putting all of that material into your head. Okay? Now, on a simpler one like this, okay, probably could get by doing it. Okay? But you might have a 3 by 3 matrix times a 3 by 3 matrix. And then you got a lot of stuff going on. Okay? Let's try another one. Give you a moment again to write down. I'll read them off for you so you don't have to keep looking up. So the left matrix is 2 by 2, 4, -3, 2, and 1. 4, -3, 2, 1 for the left matrix. Right matrix, also a 2 by 2, 5, 0, -1, 3. 5, 0, -1, 3. Okay? Dimensions, left matrix. 2 by 2, dimensions, right matrix. 2 by 2, multipliable. Result, 2 by 2. Okay? So I'm going to make myself a 2 by 2 matrix. This is row 1, column 1. This is row 1, column 2, row 2, column 1, and row 2, column 2. So I'm going to take my first row times my first column. So that would be 4 times 5 minus 3 times negative 1. First row, second column. 4 times 0 minus 3 times 3. Second row, first column, 2 times 5 plus 1 times negative 1. Second row, second column, 2 times 0 plus 1 times 3. This is 20 plus 3. This is 0 minus 9. This is 10 minus 1. This is 0 plus 3. So my 2 by 2 result is going to be the matrix 23, negative 9, positive 9, positive. Questions, comments, concerns, clarifications? Good. Try that one. Do it again. Left matrix is a 2 by 2 matrix. 5, 4, 3, 2. 2 by 2, 5, 4, 3, 2. Right matrix is a 3 by 2 matrix. 6, 4, 5, 2, 3, 1. 6, 4, 5, 2, 3, 1. Dimensions left, 2 by 2. Dimensions right. Resultant multipliable. No, so this is not possible. Those two dimensions, if these two right here don't match up, you're done. All right, so on this particular one, I would like you to first find me matrix A times matrix B, and then I would like you to find me matrix B times matrix A. I'm going to give you some time to do this, because I'm going to let you guys do this on your own, and both of them work, just so you know. Okay, both work. So the dimensions of A are, I've got 2 rows, 3 columns. The dimensions of B are, I got 3 rows, 2 columns. Okay? So AB would be of the 2 by 3 times 3 by 2, doable. Yes? Result is going to be a 2 by 2. Okay? So I'm going to take the first row, times the first column. So that's going to be 1 times 6 minus 3 times negative 5 plus 7 times 3. Then I'm going to take the first row times the second column. That's going to be 1 times negative 4 minus 3 times 2 plus 7 times 1. Then I'm going to take the second row times the first column. That's going to be negative 1 times 6 plus 2 times negative 5 plus 0 times 3. Then I'm going to take the second row times the second column, and that's going to be negative 1 times negative 4 plus 2 times 2 plus 0 times 1. So that's 6 plus 15 plus 21, negative 6 minus 10 plus 0, 4 plus 4 plus 0, negative 4 minus 6 plus 7. So I get, what's that, 2142? Negative 10, negative 3, negative 16, and 8. Otherwise, you can do it all in your head. You know what I mean? That's a you call. Okay? I'm gonna look at the answer. If you don't get the answer right and you got no work to show, I can't give you work points. You know what I mean? So I mean, if you can do it in your head, be confident, but be right. Yep. Yep. All right. Back up here. I'm going to do some erasing first. Okay. So now we got to do b times a. So that's going to be a 3 by 2 times a 2 by 3. Is that doable? Yes. Okay. Result is going to be a 3 by 3. Okay. So I'm going to take first row times first column. So that's going to be 6 times 1 minus 4 times negative 1. Then I'm going to take first row times second column. 6 times negative 3 minus 4 times such as positive 2. Then I'm going to take first row, 6 times 7 plus, oops, that should be minus. Minus 4 times 0. Then, second row, first column, is going to be negative 5 times 1 plus 2 times negative 1. Then times the second column, negative 5 times negative 3 plus 2 times 2. Then times the third column, negative 5 times 7 plus 2 times 0. Then third row, first column, 3 times 1 plus 1 times negative 1. the second column. 3 times negative 3 plus 1 times 2 times the third column. 3 times 7 plus 1 times 0. Six plus 4, negative 5 minus 2, 3 minus 1, negative 9 plus 2, 15 plus 4, negative 18 minus 8, 42 minus 0, negative 35 minus 0, 21. Okay, so I get 3 by 3 matrix of 10, negative 26, 42 is my first row. Negative 7, 19, negative 35 is my second row. 2, negative 7, 21 is my third row. Ten, negative 26, 42, negative 7, 19, negative 35, 2, all of it. Okay. Again, order matters with matrix multiplication because we did the same two matrices, multiplied them in different orders, and got very different results. Okay. You now have enough in your toolbox to finish this week's gold homework. You will have a summative quiz tomorrow in class. Okay?